Hey CC Tutors of North Olmsted, this is for week 16. We have two experiments today. Number 189, which is Shape Up, and then number 190, which is Breakthrough. And for Shape Up, we're going to connect things that we had learned previously in last semester. So we could ask, we're going to talk about the center of gravity, and you can ask questions about what the Earth does, how we stay on the Earth, if gravity pulls all objects at the same rate. And then you guys have also been learning weeks 16, 17, and 18 science is Newton's laws of motion. So you can connect that to what we learned that week 16, this is week 16. So you would have learned the first law of motion about movement, that they tend to move in a straight line at a constant speed unless an outside force acts upon it. So the force that we're going to talk about today is gravity and how it affects each box for week 16. So there's a lot of stuff in it. You'll need the bag for the first one, number 189. Okay, and we'll also have two books. These are mine from home, but we'll use hymnals at the church since they're all the same size. So we have a setup. We have books underneath two of the table's legs. And we have three objects: a marble, canning lids masking taped together, so it'll have a rim, and then masking tape. This is kind of old, but it works. If we were to drop all three of these objects to the earth at the same time, gravity is the same force acting upon all of them, so they would all land at the same time. Rolling speed is a little different because they are going to, well, first they're being pulled down to the ground by gravity, so they're going to want to roll to the end of the table. Center of gravity. Each object has a different center of gravity. In the marble, the center of gravity is compact. All the glass is right around the center, so all the weight is at the same place. In theory, this should roll the fastest. You don't have to tell all of this to the students first. You can just let them observe and play at first. Then this canning ring has some metal, but it's pretty lightweight, so the center of gravity is in the middle and there's a little bit of weight around the outside. With the masking tape, most of the weight is going to be around the outside, furthest away from the center of gravity, so this in theory should go the slowest. So usually we'll need a helper to do all of this, and of course I only have one hand, so you'll need three of your students to let go at the same time. Let me see if I can find some helpers. Tape on your mark, get set, go. All right, so the marble one, canning lids were second, and the masking tape was third because of all the things we talked about. Thanks, girls. So that experiment may lead right into our next one, number 190, called Breakthrough. I started talking about it already because if you drop objects at the same, two different objects, like the marble and the masking tape, from the same height, they should hit the floor at the same time. But there is something called air resistance. So the next one, called Breakthrough, is going to demonstrate that. Certain objects cut through air resistance better than others. So we're going to have a flat piece of paper and a cone. We have all kinds, I have enough, you can do this as a demonstration with the kids. It may take up more time if you let them work in partners or even individually. I have enough supplies for them to do individually, but you as the tutor can decide what you'd like to do for that. I will go ahead and make these two things with our supplies, the scissors, the tape, the rulers, the compasses. I've got it all in here. Okay, the first step is to draw circles that are 8 inches in diameter onto each paper. So these, I realized, are kind of cheapy compasses. I had to actually measure. It doesn't have one of those little things at the top to help me measure how many inches. So remember, diameter is the full length of the circle. So you'll want to measure this to be 4 inches long. So this is kind of fun for the kids to learn how to do. Then you put your pointy part in the middle of the circle and keep it steady as you draw a circle. So I've cut both circles out. On one of them, I cut a slit from the edge all the way to the center of the circle and then fitted them together to form a cone. I put a little piece of tape. It says to keep, if this is 1 inch tape, then keep this 1 inch tape. So make sure they're the same so that the weight is equal. We want to keep the variable to the shape of the paper, not the weight of the paper. And then we're going to stand. Let's see if we can do this to show you. And we're supposed to, at the same time, drop them and see which one hits the ground first. And you'll notice the cone should cut through the air resistance and the flat paper should flutter to the ground. Yep, and that is what happened. Then you can talk about air resistance. Definitely look through your week 16 to talk about shapes and engineering and how they happen. This is still week 16, so we've only talked about the first law of motion, but you can tap into week 18's. For every action, there's an equal and opposite reaction, how air resistance pushes up against the air, and how this affects how they engineer airplanes and parachutes and all kinds of cool stuff. So take the time to read through all of this so you can have a discussion about it, and definitely start off by asking questions, getting them interested in what you're talking about. Don't just do the experiment and expect them to be excited about it. Get them involved, get them talking, and get them to want to know more about why air stops. It's kind of hard to do, but we can do it. Talk to you soon.